So before I get started, a lot of what I'm going to talk about here is about WebRTC. Is it worth doing a bit of an intro to WebRTC, or is everybody here familiar with it? Who wants me to do a bit of an intro, or who wants me to just skip over that bit? Should I do the intro? Should I skip over it? Hands up if you want me to do the intro. Hands up if you want me to skip it. Okay, skipping it wins. So I'll skip through the first few slides. So I will start at this point where I'll say that, you know, with WebRTC there was a rather controversial but wise decision made, which is not to specify how the signaling should work. And the benefit to having done this is that it means that people can pick what is right for their application. But the downside to that means that while WebRTC gives you this great way to establish media between, to exchange media between two endpoints, what it doesn't do is it doesn't let you find out where the person you want to communicate with is and do that handshake to set this up. Now, a lot of people say, oh, well, you know, WebRTC doesn't require signaling, but it does. Even the most simple proprietary REST exchange is signaling. It may not be standardized signaling, but it's still signaling. And so in the telecoms world, we've long talked about this signaling trapezoid, where your signaling goes between your user agent, your client, and your server. And then you may have one or more servers there which exchange signaling, but the media goes direct. And this is really what WebRTC does. But the key thing here is, while signaling tends to be interoperable, if you use a standardized signaling scheme, you don't actually have to write interoperable apps. So when you're using things like Asterisk and Kamailio, these are SIP-based. That's a standards-based interoperable signaling scheme. But the fact that the signaling is interoperable doesn't mean that you have to write an app that's interoperable. Your app can still be its own little island. But the benefits of using an interoperable scheme means you can reuse what other people have already done, and you do have that option left for you in the future. And so this kind of section of the sort of track is to do with service providers and enterprise. And sometimes you do need this interoperability. And these are use cases are typically one where the point of the application is communication. Now, what I mean by that is that with a lot of WebRTC stuff, people talk about communication becoming context-based. In other words, if you're in a word processor writing a document, you may well use WebRTC to communicate and collaborate with the other people who were working on that document with you. But at that point, the point of the word processor isn't communication. The point of the word processor is writing a document, and the communication is a way of enhancing that. But there's still a lot of applications out there, conferencing, call centers, PBXs, where you need to be able to receive phone calls from customers into a business. All of these things. These are actually things that are about communication. And when you're doing this, interoperability tends to be needed. And that's where you get benefits from using platforms like Kamailio and Asterisk, which, although they support the Asterisk, for example, supports the WebRTC media, the fact that you have the interoperable signaling there makes it much easier for you to attach these systems to legacy networks. Now, when we talk about signaling options, there are so many, even standardized ones. And standards are usually best. And so the sort of three big ones I would consider that are out there today are SIP over WebSockets, XMPP over WebSockets, and OpenPeer. And the WebRTC API is easy, but signaling is often hard. Now, don't get me wrong, I'm not saying WebRTC itself is easy. What's in that library that Google have open sourced for all of us is phenomenally complicated. But because Google have provided that to us, we don't have to worry about it. We now have an easy API. The media is easy. But all of the signaling is still out there, and it's hard. But the benefit is, or the good thing is here, is that there are lots of open source libraries to do this, with lots of different APIs depending upon what you need. And that if you have hosted infrastructure, you can actually, which is often built on things like Kamailio and Asterisk, you can often, as an app developer, focus on building your application and leave this bit to other people. And so right into the nitty-gritty now. What the point of this presentation is about using Kamailio as a front end to a series of Asterisk boxes and how you go about integrating those into existing web services. And so there are three main aspects here. The first is, how do you get your signaling? How do you establish those sessions? So how do you get that session established between a browser and the network? Once you're onto the network, how do you distribute that traffic across the media servers that are actually implementing your service? And the other part of it is, how do I log on to that network? How do I identify myself in a way that is coupled into existing web services? So, WebSockets on Kamailio, SIP over WebSockets on Kamailio, it's just a transport. So anyone here who's familiar with SIP signaling knows that you can run it over TCP or TLS or UDP, and sometimes even over things like SCTP. WebSockets is just another transport in Kamailio. And what that means is, if you're a user of this platform, you can, with one or two additional changes to your configuration, you can just enable WebSockets. And all of a sudden, you're able to have this communication between browsers and your network infrastructure. In order to do this, you do need a few Kamailio modules in use, installed. You need the stateless module for the SL module for stateless replies. You need NAT helper or outbound, because there are specific things in how SIP over WebSockets as a protocol works. That means you need to do certain types of NAT traversal on the signaling. You need the XHTTP module, which implements a web server in Kamailio, and you need that because when you establish a SIP over WebSocket connection, you start off by sending in a normal HTTP GET or an HTTP GET with some special headers, which means you need to be running a web server to do this handshake. And of course, you need the WebSocket module itself, which is responsible for hooking into the Kamailio core and implementing this transport, and it takes care of doing all the WebSocket framing and encoding and other things that WebSockets requires that's a little bit different from things like TCP and UDP. Now, the most important thing when you're doing any form of signaling with WebSockets is to realize that WebSocket clients are always behind a NAT. They're always, in effect, behind a network address translation device. And this is because inside a web browser, inside this JavaScript environment, an application cannot know what the IP address and ports that it's using are. And what that effectively means is that if you're using a protocol like SIP, which embeds these things into the signaling, you just have to make something up. And to the outside world, this looks exactly like you've put private IP addresses inside your messaging, and now it's gone through a NAT firewall. And so exactly the same techniques that you use to address this NAT traversal in ordinary day-to-day SIP, you just have to do that all the time with WebSockets. But fortunately, in Kamailio, there are several modules that actually help you do this, and two of the ones that are best are NAT helper and outbound. So if I'm on Kamailio here, this is a Kamailio config fragment. If I want to set Kamailio up to do SIP over WebSockets, the first thing I need to do is make sure that when a WebSocket handshake comes in to Kamailio, Kamailio does the right thing and handles the handshake. So here we have an event route for handling HTTP requests, and installing the XHTTP module makes this event route work. And so the first thing I do is I tell Kamailio that for this request, I want the connection to be closed immediately on sending a reply, and that I also want to make sure that replies go down the same connection that the incoming request came in on. And what this means is that should anything go wrong, and I decide that this WebSocket handshake doesn't work, and I get through maybe to this 404 not found in send this reply, that TCP connection is closed down immediately. It doesn't remain open for whatever the lifetime of a TCP connection happens to be on this machine and tie up resources. The next thing I do is I look for specific things in the headers of this HTTP GET that I've received. So first of all, I'm checking $RM here that it's actually a GET. The second thing I'm doing is checking to see if it's got an upgrade header with the word WebSocket in it. And the third thing I'm doing is checking that it's got a connection header with the phrase upgrade in it. If it's got those three things in it, then what this is telling me is that this is a HTTP GET that's designed to initiate a WebSocket connection. There's a whole bunch of additional WebSocket headers in there that the WebSocket module itself checks, but this is a basic sanity check saying check these things before handing it to the WebSocket module. One of the really useful things about SIP over WebSockets is it opens up a variety of new authentication mechanisms to you, because you can actually do authentication based on the contents of this HTTP GET. You can actually do authentication at the handshake rather than waiting till signaling messages get exchanged. And this is really useful because it's more efficient. You know, if somebody sends in something and that is going to come into your network, the earlier you can reject it if you're not meant to be handling it, the better. So here, I can validate as required by looking at various headers that have appeared in this HTTP message. The host header will tell me what web page, what web server these were served from, and perhaps I only want to be dealing with traffic that's come from my website. The origin header will give me similar information. The cookie header, it may well be that I'm actually using cookies to do authentication, and therefore I want to inspect the cookies and the contents of the cookies that are in this request. Now, assuming I'm happy with all of that, I then call WS handle handshake. And at that point, this will do some additional checks on WebSocket specific headers in that GET, and if everything matches up, it will turn this from being an HTTP connection into a WebSocket connection. It will store all of that state in Kamailio, and from this point onwards, any messages received on that connection will go through the WebSocket framing code and then be put into Kamailio core as if they were SIP messages that come in over TCP. So from this point onwards, it's pure SIP, and all of your standard Kamailio routing takes effect. Now, I mentioned that there are NAT issues with WebSockets. So what you need to do is you need to make sure that you do standard Kamailio NAT traversal techniques. There are lots of tutorials on how to do this, on the Kamailio websites and in the Kamailio knowledge base. But in here, in a simplified way, if you looked at the default Kamailio config file, you would see this root request in it. I'm here now saying, after you've done that, go to root WebSocket detect. And in WebSocket detect, it simply looks to see, is the protocol for this signaling that it's come in on over WebSockets or secure WebSockets? If it is, you call this force our port, and what that does is that forces responses to go down the same connection that the request did. And then if it's a register, I call the appropriate NAT helper function to deal with registers. And if it's any other dialogue forming request, I do what's called contact aliasing. In the standard Kamailio config, there's a root within dialogue, and inside there, I just make a little change where I say here, handle the request URI alias. As soon as I've done that, what that now means is that some extra information gets stuck in all of these SIP messages that are going through my system, such that the NAT traversal and the signaling happens, and this just ensures that your SIP messages in both directions go to the right place. And of course, that's dealing with requests. Dealing with responses, simply on reply root, which in Kamailio gets run every single time a reply is seen. So a SIP reply is seen on Kamailio, this runs, and again, if the protocol for this reply is WebSockets or secure WebSockets, and the status is a 100 or 200 class response, you add the contact alias. And by doing that, that takes care of all your NAT traversal, and that's all that you need in order to set up SIP over WebSockets and Kamailio. If you take the standard off-the-shelf Kamailio config file and apply these changes, that will be SIP over WebSockets working. Now, once I've got my SIP over WebSockets coming in and out of Kamailio, I now have to deliver that traffic somewhere. And what I want to do is I want to deliver it to some Asterisk servers, and many Asterisk servers. And so the way you do this is with load balancing. Now, there's many modules to do load balancing on Kamailio, and Dispatcher is actually the simplest one of these. And Dispatcher, it load balances the traffic across set of SIP destinations. It gives you a whole list of different algorithms for doing it, and it can even keep an eye on these destinations to work out which ones are alive, and automatically fail traffic over between them. And if you want to implement a simple load balancing without failover, it's as simple as saying, calling this DS select destination, and the first one says the group. You set your load balancers up as groups. You give them numbers, group 0, group 1, group 2, and the algorithm you want to use, which is algorithm number 4 is round robin. And should you fail to select a destination, you just return an error code. Failing to select a destination means there's none available, so the call can't be delivered. This is all that you need to do if you've got multiple this is all you need to do if you've got multiple Asterisk servers, is a simple little bit of config like this, and your traffic will end up load balanced across them. Now, if you want to do failover, you need to set a whole bunch of extra options up in Dispatcher, and then you need to set up some failure routes. And there are actually some really good examples for this, so I'm not going to go through them because they become complicated enough that they don't actually fit neatly on some slides. And before, a minute ago, I was talking about groups. This is how you set up Dispatcher. You can just call these Kamailio control commands to add a device into group 0, and you just specify SIP addresses. That's all you have to do. So for every single Asterisk box you have, you would simply call one of those camctl lines, and that adds it into the Dispatcher, and then you're ready to go. And so the final step of all of this is, okay, so now my Kamailio server can receive SIP over WebSocket traffic. I can distribute this over a whole bunch of Asterisk servers, but I want to tie this into an existing web service. This could be Facebook, it could be Twitter, it could be something else entirely. Now, the problem you have when you do this is that you don't necessarily have access to the accounts on those services. If it's a third-party service, you don't have access to those accounts. If it's a service that you yourself own, you probably have access to those accounts, but I really hope if it's out there on the internet today, you have encoded the usernames and passwords in a way that means should somebody break into your service, they're not going to be able to find out the usernames and passwords for all of your users. The problem with that is you now can't reverse engineer those to provision them onto your SIP network. So you need some way of making your SIP network able to authenticate off of an external party. And one of the ways you can do this is with OAuth2. And so I don't know how many people are familiar with how OAuth2 works. There must be people here who've used things like TripIt, though, where one of the options you have is to log in with Facebook. You can log in with a TripIt account, but if you don't actually want to create an account on TripIt directly, you can log in with Facebook. And you can do the same thing for signaling, for logging into the signaling network. And so the way that this works with OAuth2 is the first thing that happens is the client loads an authentication page. And so log in with Facebook, loads the Facebook page, you enter your Facebook username or email address, you enter your password, and it will return with an authentication code. At this point, the device can go into the network over REST, providing this authentication code, and then the network can contact that OAuth2 provider, providing the authentication code, and it will then receive an access token back. It can request an identity, it will receive an identity back, and it can go back to the device and tell them what the identity is. Now, what this means on Facebook is when I log into Facebook, I log in either with my email address, my personal email address, which is peter@dunkley.me.uk, or I log in with my personal phone number. But I might change my email address one day, and I might change my phone number one day. But that's okay, because within a system like Facebook, I have an identity that doesn't change. In Facebook's case, it's a 10-digit number. And so what this happens here is at the end here, this device now has the Facebook identity or the OAuth2 provider identity of the person who's logged in. And this will never change, even should their credentials change. And that can then be used as your identity on the signaling network. So how would we do this on Kamailio? Well, there's some important things here. You need to make sure that you don't actually require any authentication, any communication between the authentication server and Kamailio. You need to make sure that when you've logged in, these credentials expire. The fact that I've logged in once with Facebook shouldn't mean I can then go back to the network again and again and again and again without revalidating. One of the benefits, as I said before, to SIP over WebSockets is you can do authentication on the handshake. Now this is really good because this means that all of these credentials and all of this authentication that I do, I can actually embed this in my WebSocket handshake. So I don't actually have to do authentication at the SIP stage of things. I can actually do it on first connection. And even though I've done this authentication at first connection, I really still want to check what's in the from and the to URIs of SIP headers, because now that I've logged on as Facebook, I then, as Peter Dunkley, I don't then want to be able to claim that I'm Andy Smith on the network. And so there's a mechanism we call ephemeral authentication that can do this. And so this top half from here upwards is what was on that picture on the two slides ago. OAuth2 communication between the client and the web service, REST communication between the client and the web service that you've implemented, and the OAuth authentication. So at this point, this device here has the identity of the third-party network and some credentials that are provided by this web service. At that point, it can create a SIP connection to the SIP proxy, which can validate those credentials to decide whether to admit you or not. And once you've been admitted, can pass you on to the media server, which in this case is Asterisk, to decide in order to actually run the service that you've implemented. And so how do we do this? So in Kamailio, there's a module called Ephemeral. And if you load that module, inside your handling of the HTTP handshake, I would just extract some headers that my client has embedded in this handshake. It will then run those headers through the authentication module. It'll cache also in a hash table. Run through the authentication module. If you're allowed, if the credentials don't match up, it will reject you. If the credentials do match up, it will then go on and do the WebSocket handshake. Should the WebSocket handshake be successful, it will cache the username, the identity that this third-party thing has provided in a hash table. And of course, just for belts and braces, when the WebSocket closes, it'll remove that entry from the hash table to keep things nice and clean. And then once a SIP request comes in the WebSocket detect module, this is now changed. It extracts the username from the hash table. It checks to make sure that this credential is still valid because it may have expired. And then it checks the to and the from headers, depending on the circumstances, to make sure you're not spoofing anybody's identity. And simply by, again, including this code in the standard Kamailio configuration, you can now do this authentication against a third-party web service. What this effectively means is you can have a secure SIP network with no user accounts on it. You don't have to create user accounts at all on your SIP network. You can deploy it out there. You can integrate it with any service that happens to be out there providing identity. Yet it's still secure. It's impossible for people to spoof identities. And that's how you tie Kamailio, Asterisk, WebRTC into existing services. It's complicated, so now's the time for any questions if anybody's got any on. You already know the answers. I know you're using it in production. Actually, I do. Unfortunately, it's not tied into Asterisk, but Andy Smith up there is helping me with a demo, so I can actually show you an example of how this works. So here, we've got a service that we call Decision Talk, and there's a login with, oh, not that page, whoops. Here we go. Let me make that a bit smaller, because it looks like the... Here we have a service called Decision Talk, which is a WebRTC communicator style application. As you can see, it says sign in with Facebook. So if I click sign in with Facebook, I've previously logged into Facebook on this computer, so it should log me in pretty much automatically. Are you logged in, Andy? You logged in? So Andy Smith's going to log in a minute. As you can see, he's actually here. There we go. What's happened here is that this is a list of all of my Facebook friends who've previously logged in with this application. So this application is now listed as one of their Facebook apps. So I've now logged in, I've registered on the SIP network using my Facebook ID. Incidentally, my unchanging Facebook ID is 1015240286734400. I said 10 digits, I think it's actually more. Anyway, that's my Facebook ID. And this is downloaded my Facebook contact list, but it's only allowed, because of Facebook security rules, to access the contacts who already also have the app, one of whom, as you can see, is Andy Smith, and because he's online, he's green. And as a result, I'm going to call Andy. Doesn't really work very well on this small screen. Who hopefully, fingers crossed. Oh, I hate demos. Well, you heard it ring. Here we are. Hi, Andy. Right, so that's an example of what you can do there. And yeah, there we go. And now he's hung up. Well, we're not using a media server at all. That's the point I'm saying. Unfortunately, I don't have an Asterisk demo, but Tori asked if I had one that showed how this ephemeral authentication works. I have one other example which I'll show you just because it's a little bit of fun, which is, well, I'm having a, where's my mouse? Here we go. Which is noughts and crosses. And this is with a OAuth server that we built ourselves. So this isn't a third-party one. This is an OAuth server that we actually built ourselves. And I have a mobile version of this app, because of course you can use OAuth 2 for logging in off of mobile devices and other things as well. It's not just tied to web pages. Here I'm going to invite test00 to play a game. And what I have here is a game of noughts and crosses. Oops. And oh look, I lost. And again, that was all logged in using Auth2, which means that on the network, the network that's deployed out there behind the scenes here, it doesn't actually have any users or passwords or anybody on it whatsoever.
Lots of time for more questions. Anyone else?
More questions?
Questions? Questions? Anybody? Anything else you'd like to add, Peter?
No, not really, other than to say that, of course, the slides for here will be available. This is one of these things that's actually pretty hard to explain. I've tried my best, but it is very hard to explain. But the slides are available. And like I said, if you were to take those config fragments that are in those slides and apply it to the default Kamailio config file, you will have all of this working.
Okay, for the game, do you have particular extension? You do it via signaling or you do it via RTP? Like the signaling, or how is the game done between the players?
Okay, well the game is using SIP signaling to establish the video session, and it's using WebRTC to send the video, audio backwards and forwards, and then it's using a proprietary REST-based protocol for the actual messaging that sends the game messages backwards and forwards.
Okay, so the moves are via the RTP channel? Or
Yes, so the moves get transmitted via a proprietary REST messaging protocol. They're actually just encoded as JSON object. There's just little JSON fragments that are sent backwards and forwards between the devices.
Okay, thank you.
Anyone else? Any other questions? Oh, one all the way over there.
Between Asterisk and the WebRTC going all the way to Asterisk. Is Asterisk doing WebRTC or is Asterisk only doing SIP?
Asterisk does WebRTC. The WebRTC profile, which is what they call RTP/SAVPF, has been in Asterisk since sometime in Asterisk 11, late version of Asterisk 11, and so is SIP over WebSocket support. But when you use SIP over WebSockets into Asterisk, you can't really do any sort of header inspection and extra security checks on the handshake. So my experience has always been that it's better to put something like Kamailio in front that can do some extra checks, like, does this person have the right cookies? Are they from the right web server?
So media is not, we don't need to look at media with something like RTP engine in between.
Yeah, exactly. So with Asterisk, you don't have to worry about RTP engine. Of course, RTP engine, which has been developed by the guys at SIPwise, isn't it? Yeah, SIPwise. There is a Kamailio module for driving that, so that does mean if you weren't interested in Asterisk here, if you wanted to break out to the PSDN, you can use Kamailio with RTP engine to convert from the WebRTC media profile to an older style SIP profile that your ITSP is likely to understand.
Perfect. Any further questions? No? Nobody? Nobody? Come on. No? All right. Well, if you do think of anything, I'm sure you'll see Peter around the next few days. Let's give Peter a round of applause.
Thank you.
I also encourage you to fill out the survey about the speakers. Digium really, really relies on your feedback and takes your comments very, very seriously. So fill them out. There's spare forms there. And of course, you'll be entered to win a Chromecast. So our next speaker should be along probably in about